Okay, so example 4 from 8.2, the first thing that we need to do is factor. So this is a difference of two squares, which would factor into x plus 1 and x minus 1. And then from there, we need to identify what the LCD is equal to. So everything has to be represented. So looking down here, I can see that I need an x minus 1. We also need an x, so we'll include that. And then this part here, we have both x plus 1 and x minus 1. Since x minus 1 is already accounted for, the only other thing we need is an x plus 1. So now, from there, what we will do is get everything that is missing within each denominator. So with the first part, we are missing, and we are also missing an x plus 1. So if I put that into the denominator, for the second part, we're missing an x minus 1 and an x plus 1. So we will include that in both. And in the last part, we are just missing an x. So we will put that in both the numerator and denominator. So now all three of these denominators look identical. Okay? So we can condense this down. So basically, all I need to do is simplify each numerator. So looking at that, if I distribute the 3x through here, the result of that would be 3x squared plus 3x. For this next portion, the 2 times x minus 1 times x plus 1, I'm going to go ahead and multiply those two items out. So the x minus 1 times x plus 1 gives me x squared minus 1. They are a difference, or a conjugate pair. And then we can distribute the negative 2 through to end up getting negative 2x squared plus 2. So again, that is just the simplification of this. And then from there, for the second part, for the third part, x times the quantity x plus 3 would give us x squared plus 3x. So everything that is highlighted there in yellow, I can total that. This 2x squared plus 6x plus 2. So again, that's just everything that's combined, which is highlighted in yellow. And then the denominator, again, it was all the same. So that would be what our common denominator is, x times x minus 1 times x plus 1. What we should do from there is factor this just to see if anything would end up canceling. We factor out that GCF of 2. We can see if this portion is factorable. There are no two numbers that multiply to 1 and add to 3. So it ends up being our final simplification for that. Moving on to example 5, we have a word problem, and it's dealing with distance, rate, and time. So we should know the formula for distance equals rate times time. Within this context, we're given some information about the distance and the rate. We do not know anything about time. So we can express this, we can rework this formula into this, and utilize the distance over the rate. Okay, so the expression that can represent Kendrick's total exercise time would be the amount of time that he spends walking and the amount of time that he spends jogging. So the distance and rate in which he walked can be 1 mile over the rate at which he walks. So that's the distance he walks, the 1 there, and the W is the rate at which he walks. Since we are told his jogging speed is 4 times his walking speed, the way that we can work that is say that this is representing jogging speed, which is again 4 times his walking. How far did he jog? He jogged 5 miles. That's where this 5 is coming from. So now we just have a matter of combining that. Our common denominator would be 4W. So this portion would be the 4. So we can multiply numerator and denominator by 4. And when we rework that, that'll give us a 9 over 4W. So that represents his total exercise time. How many minutes did he exercise if his walking speed was 3 miles per hour? All we have to do is plug in 3 for W. So we take that expression that we had from part A, plug in 3, 3, that gives us 9 over 12, which reduces to 3 over 4. 3/4 is 45 minutes. All right, this last one, it looks really ugly, but it's not too bad if we break it up into pieces. So for the first part, you can see what I have written, drawn down here. We're just going to go ahead and combine that, getting a common denominator. So the LCD for this and this would be y times 2y plus 1. So this needs a 2y plus 1. And the other portion needs a y. So when we combine that, this would end up being our result. We would do 5 times 2y to get 10y, but then have to subtract the 6y for the second part. That would give us that total of 4y. And then 5 times 1 gives us the 5. So this represents the result of this. Okay, condensing that down. The other part's a little bit easier. So if we look at this component, the 4 is technically 4 over 1, so what we would need with that common denominator would be y, so we have to multiply numerator and denominator there by y, which when we combine that gives us this, 5 plus 4y over y. So now